Number 5, we have a series question and they want us to use method of difference to prove that it can be rewritten in that form. Okay, let's begin. We have 4 over r squared minus 1. Let's first express this in partial fraction. In order to express this in partial fraction, we have to rewrite our denominator in factored form. This is actually r squared minus 1 can be rewritten as r squared minus 1 square. Difference of 2 square. That means the factored form is r minus 1, r plus 1. So 4 over r minus 1, r plus 1 is equals to a over r minus 1 plus b over r plus 1. So this is our partial fraction. How can we find or how can we figure out the value of a and b? We have to first multiply this equation by the factors. So r minus 1, r plus 1. So what happened when we multiply by this? We will get this. So here would be r minus 1, r plus 1, r minus 1, r plus 1. Okay, let me erase this part. So why do we choose this? Because we want to eliminate the fraction. There we go. We have 4 equals to a, r plus 1 plus b, r minus 1. Next, we need to find two values of r that we can substitute into equation 1 so that we can find the value of a and b. Let's first begin by finding each root. Okay, r plus 1 equal to 0. That means r equals to negative 1. r minus 1 equal to 0, that means r equals to 1. These two values should be substituted into this equation. So let r equals to negative 1 into 1. So 4 equals to a. Negative 1 plus 1, that is 0, plus b. Negative 1 minus 1, that's negative 2. So negative 2b is equals to 4. B is equals to negative 2. We're done. Let's move on to the second value. And let r equals to 1 into equation 1. 4 is equal to a. 1 plus 1 is 2. Plus b. 1 minus 1 is 0. Therefore, we have 2a is equal to 4. A is equal to 2. Let's rewrite our partial fraction. So, we have our series r from 2 until n. 4 over r squared minus 1. This is equal to r equals to 2 until end. Okay, let's begin with a. Okay, a 2 over r minus 1. And then we have negative 2. That means we can put minus here. And then 2 up here. Okay, so this is more the series sign. So from 2 until end we have negative. Okay, here would be r plus 1. Let's do the series separately. Let's expand them. Let's begin with the orange one. Let's first substitute 2. So 2 over 2 minus 1 plus 2 over 3 minus 1 plus 2 over 4 minus 1. Okay, we have 3. And then we can just put dot 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 and the last three. What are the last three? It would be n minus 2, n minus 1, and n. So 2 over n minus 2 minus 1 plus 2 over n minus 1 minus 1 plus 2 over n minus 1. We are done with the first expansion. Let's continue with the second one. This is from the olive series. So 2 over 2 plus 1 plus 2 over 3 plus 1 plus 2 over 4 plus 1. Just 3 would be enough, and then you put dot dot dot, and let's do the last 3, which is the same thing. So 2 over n minus 2 plus 1 plus 2 over n minus 1 plus 1 plus 2 over n plus 1. That's it. Let's expand and simplify the numbers. So I will get, 2 over 1 plus 2 over 2 plus 2 over 3 plus dot 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 plus 2 over n minus 3 plus 2 over n minus 2 plus 2 over n minus 1 minus 2 over 3 plus 2 over 4 plus 2 over 5 plus dot 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 plus 2 over n minus 1 plus 2 over n plus 2 over n plus 1. Okay. Now let's see, we have some values that we can add on in the middle to make sure that when we cancel the terms, it will be easier to cancel the terms. Okay. Let me continue with our computation up here. Okay. So now, we know that the numbers here, right, actually add up by 1. It keeps increasing by 1. So what I can do is I can add on. I know for sure after 2 over 3, I have 2 over 4 and 2 over 5. And that's it. I can continue with the plus. Dot, dot, dot. Okay. And then the same thing here. If I reverse, I know that before n minus 1 is n minus 2. And before n minus 2, I would have n minus 3. That's the reason why I put it like, the orange series at the top and the olive series below. That is to make it easier for you to cancel the terms. Okay, let's start cancelling. 2 over 3 can be cancelled by 2 over 3. 2 over 4, 2 over 4. 2 over 5, 2 over 5. That's it. Notice that I can cancel this with this. Now, we can just write down all the balanced terms. I have 2 plus 1 minus 2 over n minus 2 over n plus 1. Why is this 2 minus? Because I distribute the negative sign here. See, this negative. So when I distribute, both of the terms would be negative as well. Okay. So here I have 3 over 1 minus 2 over n minus 2 over n plus 1. I want to combine these three fractions so that it becomes 1. So I have to multiply the first fraction with n plus 1. And then the second one, just n plus 1. And then for the third one, I have to multiply by n. Okay. That's it. Let's expand the numerator. We will have 3n square plus 3n minus 2n minus 2 minus 2n over n plus 1. Okay, so here it will be 3n square minus 3n minus 2n minus, okay, that will be minus n minus 2 n plus 1. Next, we have to factor our numerator. We can simply use our calculator. Okay, go to equation, polynomial degree 2. Okay, coefficient is 3, negative 1, negative 2. Okay, the first value of n is 1. And the second one is negative 2 over 3. We want to find factor. So when we want to find factor, we have to make it equal to 0. So n minus 1 equal to 0. Here you have to bring the 3 up first. So 3n equals to negative 2. 3n plus 2 equal to 0. Now both of these are equal to 0. So we know this is the first factor and this is the second one. So that's it. The first one is n minus 1 and the second one is 3n plus 2. Okay, equals to n plus 1. We can now erase this. We do not need to show that. Okay. With that, we are done. We managed to prove that it looks like that. So this is our answer for question number 5. That's it.